everyone. Good afternoon. Now, today I have brought two problems, and these two problems are very, conceptual. We can say, or there's a lot of students they're committing mistake in between. So I drag your attention to these two problems. So it will going to be boost your preparation and confidence both. And these problems are basic linking problem, and you can come across so many time in previous 10 years these type of problems. So let's bring the discussion on, but before that we can say this is these two questions are the part of JEE main and advanced 300 question series. These are the two one of the problem, and I keep bringing these series nearly daily, so please check it out and enrich your knowledge and confidence. So here the problem number one, here you can see the two block system, and the block one and block two, 3 kg and 6 kg placed in a smooth horizontal surface, and they are connecting with the spring. These are spring system through which is connected. They have given a spring constant, and initially the spring is unstretched. And let me tell you, unstretched means what? Now here we can say we can compare this situation as pendulum situation. Like here you can say this is a pendulum, and pendulum will be at rest. This is called mean position. Fine, mean position. And once you start pushing from its mean position to what it will to go to the extreme position. Fine, extreme position. So mean position, this is the extreme position. In the same way, in a spring block system, let's say this is unstressed situation, and once we push, so spring will let's say compress. The spring will go to some x distance compression, and once again it will return back to its, this is once again called mean position, and once again it will go away to same x extension. So this is somewhat SHM. This motion is called as simple harmonic motion. So we can assume this block is also executing somewhat SHM about its position. So kindly keep this fact in mind. Even the two block system is there, it will simply behaving as a pendulum. Fine. Now the initial velocities they have imparted, these are the initial velocities we can say they have imparted the maximum extension of the spring that we are looking for. What is a maximum extension in the spring? So maybe the case the spring start stretching and attain some maximum extension. This is what we have to x max we have to calculate here. Fine, x max we have to calculate here. So you know very well the velocity once we have imparting to the system. So velocity will trying to make the block move away up until this spring will not going to be stretched at the maximum position. And when the spring will get the max extension, so these two block will going to be stop at that point. So we have to discover this x max. So we can say we can directly use work energy theorem to get this extension. So now I keep dragging your attention to the part, please note it down because I will just go and explain point wise to this problem. Basic, I thought you have understood what we supposed to calculate, and the next important part we have to calculate here, what is the maximum and minimum velocity of the block during the motion. So maximum and minimum. So once again, if I compare it to the block system, to the spring mass system, we can say this is mean position and mean position. When the block will go to a extreme position, the velocity will be here, velocity will be zero, and once again it will return back to original position. We can say v will be max. So roughly we can say once the spring will move to the mean position by distance x, it will velocity will be 0. And once again it will return back by x, the velocity will be nearly 0, and here the v will be max. So this is the thinking that is required if you comparing with the pendulum. So I thought this thought process it is needed to calculate the max or min. So max we can get at the mean position and min we can get at the extreme position. This is what it is required. Now, since they have given the velocity to these velocity at which position? Mean position. A mean position they have given the velocity. So we will surely get at a mean position the maximum velocity for sure. So let's start the discussion. Now here we can say these are the block system, and now here by using work energy theorem we can say maximum energy that possessed by this block two block system, it would be kinetic energy of center of mass plus kinetic energy of this two mass system, where mu is called as reduced mass. Clear? And the value of reduced mass is m1 m2 upon m1 plus m2. This will be considered as m reduced. This is what it is denoting by mu. Fine, this is the mu, and this is called vr. Vr is called relative velocity. This is called relative velocity. So here we can say since no external force is applied, so acceleration will be zero, so velocity will be constant. Means both were moving. That's the, we can say center of mass velocity will be constant. So there's a no role of extension and compression of the block. Only second term that is responsible for extension or compression of the block. That's why I have equated this velocity half m mu square is equal to half k x square max. Half k square max means once the relative velocity will going to be zero, and when it will happen the relative velocity it will going to be zero once it will be at maximum extension, then the relative velocity will be zero. And when the relative velocity will be zero, so we can get the maximum extension. But before that, let me tell you what about the next step that we have performed here. Here we can say this is a reduced mass m1 m2 upon m1 plus m2, that is 9. And relative velocity, since both of the velocities are opposite to each other, that's why velocity get added. And k it is given an x max. So here the k max we have calculated as 30 centimeter. This is the k max. I thought you get the basic mechanism because once the block will be moving away, moving away at the some point there, the maximum extension take place, and this maximum extension the both the block will be remain at rest, with respect to we can say center of mass. With respect to center of mass they will be at rest. So this is what I have applied here. I thought you got the point key what we have calculated and what is a x max. Now the next important thing is the second part. Now let's quickly see the second part. So for the second part we can say let's calculate the center of mass velocity. Center of mass velocity m1 v1 y minus, because both are opposite direction. So that is the center of mass velocity we got. Center of mass frame. In the center of mass frame, we can say earlier it has a velocity 2 and 1 respectively. This is a mean position. Okay, mean position velocity. And I told you mean position it has a maximum velocity. Now when the center of mass itself is moving with 1, so with respect to center of mass, and how we calculate, we have to add only center of mass velocity in by swapping the direction, in fine. Here we can say swapping the direction, and if we added the 1 meter, That is relative velocity only. This is a shortcut through which you can get 1 meter per second. So here we can say 2 minus 1, it will be 1. Fine. Here 1 and 1, it will be 2. With respect to center of mass, and center of mass velocity will be 0. So with respect to center of mass, velocity will be 1 and 2. Fine. Now, next important thing is, you know very well, when the maximum compression, so with respect to center of mass, both will be at rest. Both will be at rest because maximum extension means the both will be go to at the extreme position. I told you already, once it will go to extreme position, then the velocity will be 0. With respect to pendulum, I told you already. Fine. So here the velocity will be 0, but with respect to center of mass frame. If you want to calculate with respect to ground frame, so we can say with respect to ground frame, what we supposed to do here with respect to ground frame, like whatever the center of mass velocity, the same velocity will be both of the block. So here we can say 1 centimeter, 1 centimeter, and 1 centimeter. They are moving, and this is velocity of blocks. Velocity of system with respect to center of mass is velocity of center of mass plus velocity of blocks. So we can say when the both are moving the same velocity and common velocity, only then the it will be at reaching at the maximum extension. This is also another way you can see. So with respect to center of mass, both block will be rest, but with respect to ground, center of mass is still moving with 1, so both will be moving with 1 meter per second. Fine. And here you can also check with respect to center of mass. Look at, since center of mass will be having zero momentum, so both of the block, the sum of the momentum will be also 0. So here we can say 6 multiplied by 1, that is 6. Here 3 to just 6. So we can say the final momentum, initial center of mass momentum is 0. Hence the both of the block momentum will be also 0. And here you can see the both momentum is P1 plus P2 is also 0. That is equal to center of mass. By this way you can cross check as well. What is the center of mass momentum? If it will be 0, then both of the block will be adjusted in such a way the velocity, so the total momentum will be 0. So I thought you have got this point. Now we have to calculate minimum and maximum. Now this point is important. I told you already. Now this point is important here. We can say, now this is given already. Fine. So velocity of, we can say with respect to center of mass, if the block will be at a max velocity, so we will get the max velocity of the block, and when the block will be at a mean velocity, we will get the mean velocity of the block. So here center of mass velocity we have already calculated, that was 1 only. So what is the maximum value and what is the minimum value? Here we have to only add to the velocity of center of mass to get the max value of the given block in the ground frame and min value. So max value, I told you, these are the two velocities at a when it was unstretched. Unstretched means mean position. Mean position means max value. So max value we have seen 2 and 1. So once we add the center of mass velocity, we will get the maximum value with respect to ground frame. So here we can say, once we are adding, now 3 kg block, you have seen 3 kg 2 meter per second, it was given in the question, and 6 kg 1 meter. So once we are adding, so respectively V max with respect to ground we got 3 meter per second, and V6 we got 2 meter per second. Fine. Now next important thing is this, what is minimum? So minimum we have already calculated with respect to center of mass velocity. Here we have calculated center of mass. This is the final situation once it will move to the maximum position. So it was 1 and 2. Fine, 1 and 2. Now this velocity, if we're going to add here, so we can say the minimum velocity will be 1. Once we add the v6, it will be got 0. But here we get the interesting result 6 if we are added in 3 kg if we added. So it will got minus 1 actually, and minus 1 means certainly it will got 0 value as well. So for a minimum value, instead of minus 1 we will take 0. So that's why we can say minus, instead of minus 1 I'm picking, because before it reach the minus 1 it will surely attain 0 value. That's why its value will be 0 with respect to ground. So I thought these are the maximum velocities and minimum velocity in ground frame. In ground frame. So this is a trick we can say through which we can get very easily with respect to ground frame the maximum value and minimum value. So I thought this problem you have understood, and this is one of the interesting problem. And here I told you one more thing, like here the block is executing SHM with respect to center of mass. So I'm using the concept of center of mass as well, given the velocity will be max and min. So I thought this problem better to practice one. If anything, you can text me if any doubt and any area look like you have not understood. I can bring the solution of the next problem soon. Till then, take care. Have a nice time.